Here we go with the second half of the Unit 6 practice test, number 7. Let's see if you got the right answer. Use the probability distribution graph to answer the question. Hopefully you got B. This is a bit of an abstract looking problem. You have P, X, and A. What's going on here? Well, you've seen it before, but I'll explain it right now. This problem, it's giving you a statement right here. That's what that is. This statement is saying, is saying the probability that a random variable being less than or equal to a particular value on the x-axis is 0.25. Okay, so A represents the value on the x-axis we're looking for. So in other words, where you see 2 less than or equal to that, you're going to see the probability of 0.25. Because remember, we're looking at the entire shaded region. And if you look to the left, which is less than or equal to the x value of 2, that shows us 0.25 of the entire shaded area, right? This is 1/4 of this whole big shape that we saw right there. So in other words, where a discrete random variable x is less than or equal to 2, there is a 2.25 of the shaded area. So our answer is 2. Number 8. This one shouldn't take too long. The answer is A. Which data set is likely to be normally distributed? This is, once again, a diagram of normal distribution. In normal distribution, all of the values, or I should say the majority of the values, are in this area, right? Which is all very close to what? The mean. Okay, we're looking at the heights. These are all not too far away from the mean, which is right in the middle. And very few on the very, very low and the very, very high end. Now, we're talking about real life situations. The length of newborns in a hospital. Why do they say length, first of all? Well, newborns can't walk, right? So instead of height, we're saying length. And that would be normal distribution because most babies are about the same length, okay? With very, very few being really, really short and very, very few being really abnormally long, right? We're not having a 3-foot long baby, right? Or a 6-inch long baby. Now, these other two, B and C, these are more of a normal distribution, the outcomes of rolling a number cube several times. Well, a number cube has 6 sides, but the probability of landing on any of them is the same. Is that 6? 1, 2, 3, 4, 5, 6. Yeah. So that is a uniform distribution. The ages of students at a high school, that is also uniform distribution. You might say ages 14 through 18, so something like this. Like that, maybe. Okay? Where the probability is even, basically, for everything that's uniform, but that's not the case for A. Number 9. This is one of the most practiced skills in this unit. Hopefully you have it mastered by now. Okay, scores on a biology test are normally distributed with a mean of 72, standard deviation of 9. Brian scores a 67 on the test. They want us to find the z-score. If you're asked to find the z-score and you have these 3 parts of information, you should already know you're going to use your z-score formula. And it's also super important that you know what these symbols represent. X is the raw score. Which one of these values is the raw score? Well, that's the actual number value Brian scored. What's this symbol? Do you remember? Well, let's see if you got it. That symbol is going to be our mean, and then we have our standard deviation right there. So you might want to start off by labeling this. Knowing what the symbols mean is one of the most important parts of solving this. And now that we have all the information we need, we just plug it in, subtract, divide, answer. Number 10 is very similar. This time you're given what? Let's see. Researchers found a fertilizer treatment to have a mean plant height of 76 inches and a standard deviation of 3 inches. Find the height. Let's use a different color. They want us to find the height of a plant treated with this fertilizer that has a z-score of 0.25. Round to the nearest tenth. So they're giving you the mean, standard deviation, and z-score. They want the raw score. Can you find it? In this case, they once again gave you everything you need. It's just sub and solve. Sub everything in, multiply, add. There's our answer. 76.8 inches. Okay. So pretty close to average, right? Just a little bit above average. And that makes sense, right? 0.25 z-score is just barely above 0, where the mean would be. Second to last problem, I should say. Number 11, you will need, in this example, and this question on the test, your z-score table. Remember, you have that handout. If you don't know where to find it, you can always Google those tables. Here is a snippet of the piece of the table you'll need for this particular problem. And here we go. Suppose scores on a standardized test taken by future doctors are normally distributed with a mean of 10.5 and a standard deviation of 2.2. Approximately 70% of the future doctors scored less than what score? What do we have? Start there, and then focus on this approximately 70% part. And the answer is C. Hopefully you got C. If not, that's okay. You can practice and learn it better right now. Okay, I started with what I know, right? They told us the mean and the standard deviation. There they are. So I'm going to highlight those. Mean, standard deviation, those are taken care of right away. And they want us to find the actual score. Right? They said approximately 70% of the future doctors scored less than what score? They want an actual score. That's a raw score. So we're going to use our raw score formula once again. But the hang up is we don't know the z-score. So what information do we use? This right here, approximately 70%. This is not a percentile, so it doesn't have to be above 70%. If they're saying approximately 70, we want the value closest to that. Okay, so the plan is to look through your z-score tables to find the percent closest, or the decimal, I should say, closest to 70. And these two look awfully close. A little subtraction will go a long way here. To find out exactly which one's closer, I do 70 minus 69.85. Notice I had to change it, convert it to a percent. And then this value, same thing, but I rearrange the order since this value is bigger than 70. And just by 0.04%, 69.85 is closer. So that's the one we're going to go with. And we want the z-score, so we work our way out to get 0.52, plug it in, multiply, add, answer. Does that make sense realistically? If the mean's 10.5, does it make sense that 70% of them scored 11.6? Yeah, that's just a little bit above, right? And z-score 0.52, that's just a little bit above as well. And our last problem for Unit 6, try it out. The answer is D. The weights of bags of corn produced at a factory are normally distributed with a mean of 28 ounces and a standard deviation of 2 ounces. Consider a shipment of 800 bags of corn. Okay, a lot of corn. How many of the bags will weigh 26.5 ounces or less? The question is, how many of the bags? We need to know. So we're going to use some familiar skills. All of these skills actually are familiar, but solving a little bit differently than the last one. Okay, let's start with what we know. What do they tell us? They told us the mean, standard deviation, boom, boom, there they are. They told us consider a shipment of 800 bags. What is 800 bags? It's just some information. And then 26.5, that is the raw score, the weight of the bags, right? Because we're talking about a mean in ounces and a standard deviation in ounces. So we're talking about data that needs to be in the same unit of measure. We're not talking about bags, we're talking about ounces, right? So that's your raw score. And you should be thinking, great, I have a lot of good information. Let's use the z-score formula. Okay, so what do we do? What do we need? Let's see. We need raw score. We have it. We need mean. We have it. We need standard deviation. We have it. Great. We found the z-score. Okay. Now, what is that z-score going to do? It's going to help us find the probability in the tables. We go ahead and we look for negative 0.75. We're working our way into the probability to give us 0.2266. Okay, this is where you need to pay close attention because we need to go back to the question. How many bags will weigh 26.5 ounces or less? Okay, well, we just found this value, this probability in the table. But what does that actually mean? It means that 22.66% of the bags weigh 26.5 ounces or less. Okay, that's the percent, but they want to know specifically how many bags. Not a percent, how many. And just like you calculate percent of anything else, you need to take the total. So look at that, that 800 was needed and important for solving. You need to take the total and multiply times the percent as a decimal to give you 181.28 bags. And that, my friends, is the end of Unit 6. Once again, study and finish this unit strong. Next up is our final review. So come back for that as we wrap up the year.